Okay, so this is the ice sculpture problem. And this is the problem where we've got r prime of t given to us in terms of t days, and r prime is measured in terms of centimeters per day. And the first question that they ask us is, what is r double prime of 8.5, which would be the slope of r prime in terms of days. So they want us to use 10 and 7 as our times to approximate this. So to approximate, we're going to have r prime of 10 subtracting r prime of 7 divided by 10 minus 7. And this yields negative 3.8 plus 4.4 over 3, which is 0.6 over 3, which is 1/5. So 1/5 is our value there, and the units, the numerator's units are centimeters per day, and the denominator's units are days. So it's centimeters per day, or if you did centimeters per day squared, that would be sufficient as well. On part B here, part B, we've got, is there a time t equals 0, from 0 to 3, where r prime of t would equal to negative 6? Well, they tell us that this function is differentiable. In fact, they tell us it's twice differentiable, the r function is, and based on that, we know that r prime would have to be differentiable. So if r prime is differentiable, then r prime has to be continuous. And again, it's important for us to take note of that. It's because you can't just automatically say we know that r prime of t is continuous. You have to state that the differentiability requires that function to be continuous. Now that we know this function is continuous, we know r prime, the intermediate value theorem would apply here. So your intermediate value theorem applies, and negative 6.1 is less than negative 6, which is less than negative 5. So because of that, the answer is yes. There is a point where you would have to have r prime of t to equal to negative 6. Moving on to part C, this is the right-hand Riemann sum. So we're going to use, for each interval in here, from 0 to 3, 3 to 7, 7 to 10, and 10 to 12, we're going to use the right-hand value, so we will not use this negative 6.1. One other mistake that's commonly made here is a lot of times you start getting used to trapezoidal rule, which has a 1/2 in it, but we're taking areas of rectangles with these heights, so there is no 1/2 in the formula. So what we get here for this approximation of 0 to 12 of r prime of t is going to be the width 3 times the height of negative 5 plus the width of 4 times the height of negative 4.4 and the width of 3 times the height of negative 3.8, and then the width of 2 times the height of negative 3.5. And from, well, that's horrible writing. So from all of this, this would be negative 15 and negative 7, which would give us negative 22. And here we get negative 17.6 and negative 11.4, and that would give us negative 29. So that would yield negative 51 as our solution. Now, the units here would be, you're taking centimeters per day and multiplying it by days. So centimeters per day times days would be centimeters. So it's negative 51 centimeters as the answer. So that is your solution to part C. Part D is going to require related rate solving. They tell us that V equals 1/3 pi r squared h. Now, they tell us that we've got a cone, and they tell us that this sculpture is melting, and the sculpture is melting in the shape of a cone. But it does not tell us that the cone is consistent. In the original problem, they tell us that t equals 3, h equals 50, and r equals 100. Now, if this cone were a formed cone, then the radius would always be twice the height. But the radius is not necessarily always twice the height as far as this problem right here is concerned. We just know it's still a cone. So we have to take the derivative here, and because we can't substitute in, then we're going to need to use the product rule here. So the derivative of volume with respect to time at t equals 3 is 1/3 pi r squared times dh dt plus 1/3 pi times 2, so it'd be 2/3 pi r h dr dt. Now, based on this, we'll start plugging stuff in for the specific time of t equals 3. Well, we have 1/3 pi times r, and our r at this instance is 100, so it's 100 squared times dh dt, and dh dt at this point is negative 2. And it gives us that in the problem. If you're wondering where we got that from, it tells us, well, not in the problem, it tells us in part D, it says the height of the cone decreases at a rate of 2 centimeters per day. So at that instant. And then it's plus 2/3 pi. Again, my radius here is 100. My height is 50. And now dr dt, they gave us in the original problem, and at time equals 3, dr dt was equal to negative 5. So we get negative 5 here. Now, technically, for the AP purposes of AP, you can stop right here. But if you've solved it out all the way, I think if I remember correctly, it's negative 70,000 pi over 3 to get the solution there. So, those are the answers here, and have a good one.